On the sun-drenched shores of the Aegean, on the island of Samos in the 6th century BC, a man kneels in the sand. All around him is the chaos of nature, the crash of waves, the cry of gulls, the unpredictable scuttling of a crab. But in his hand, he holds a seashell. He traces its perfect logarithmic spiral. And in his mind, a question ignites, a spark that would set the Western world on fire. Is this chaos, or is it a language I do not yet understand? This man was Pythagoras, a name we associate with a theorem from our school days, but he was so much more. He was not just a mathematician, he was a mystic, a philosopher, a seeker. We are told he traveled the known world, from Egypt to Babylon, not as a conqueror, but as a student, gathering fragments of a hidden truth. And when he returned, he brought with him the most radical idea of the ancient world. All things are numbers. He didn't mean that the world was merely countable. He meant that beneath the surface of reality, beneath the fleeting and the chaotic, there exists a timeless, divine order, a hidden set of principles, of ratios and proportions that governs the fall of a leaf as much as the orbit of a star. He believed reality was not chaos, but a cosmos, a perfectly ordered and intelligible whole. His quest was to find its source code, its blueprint. Today, we will walk in his footsteps. We will join his quest to decode this universal geometric language, a language written not in letters or words, but in shapes, patterns, and proportions, a blueprint that connects the ancient world with modern science and the vastness of the cosmos with the intimate structure of our own being. This is the story of sacred geometry. Pythagoras' journey to understand the visible world began with the invisible world of sound. Legend tells us of a breakthrough, an epiphany that occurred in the most unlikely of places, a blacksmith's shop. As he passed by, he was struck by the ringing of the hammers against the anvils. Some sounds were discordant and chaotic, but others rang out in a sublime harmony. He was obsessed. He had to know why. He discovered that the hammers producing the harmonious sounds had simple, whole number weight ratios to one another. A hammer twice as heavy as another produced a perfect octave. A ratio of 3 to 2 produced a perfect fifth. 4 to 3, a perfect fourth. Here, in the clang of metal, was the proof he sought. Harmony wasn't a matter of opinion. It was a matter of mathematics. It was a physical manifestation of numerical law. He took this principle back to his laboratory, experimenting with a single-stringed instrument, the monochord. He showed that the entire system of musical harmony could be created through simple, elegant integer ratios. He had found the hidden numbers behind music. But for Pythagoras, this was only the beginning. If the laws of harmony in sound were governed by number, could the same be true for harmony in sight? Could the beauty we perceive with our eyes also be rooted in a hidden mathematical constant? His brotherhood, a semi-mystical school of thinkers, turned their gaze from the ear to the eye, searching for the music of the visible world. They found it everywhere. They found it in the pleasing proportions of a temple, in the balanced composition of a sculpture, and most profoundly, in the architecture of life itself. This principle of visual harmony is what we now call the golden ratio. Represented by the Greek letter phi, or phi, it is an irrational number, approximately 1.618, but its definition is one of perfect recursive simplicity. It is the one ratio that allows a shape to grow infinitely without ever changing its proportions. It is the principle of balanced, harmonious growth. The Pythagoreans saw it in the proportions of the human hand, the distance from the navel to the floor compared to the navel to the top of the head. It was the mark of ideal beauty, the signature of the Creator. And as they looked deeper into the natural world, they found a sequence of numbers that seemed to generate this ratio automatically. The Fibonacci sequence. Starting with 0 and 1, each subsequent number is the sum of the two preceding ones. 1, 1, 2, 3, 5, 8, 13, 21, and so on. The magic happens when you divide any number in the sequence by the one before it. The further you go, the closer the result gets to phi, the golden ratio. This wasn't just a numerical curiosity. It was nature's numbering system. The number of petals on a lily is 3, on a buttercup, 5, a delphinium, 8, a marigold, 13, a daisy, 21, each a Fibonacci number. The seeds on a sunflower head are arranged in 2 sets of interlocking spirals, and the number of spirals in each direction are almost always consecutive Fibonacci numbers. Pine cones, pineapples, the branching of trees, the spiral of a nautilus shell, all are governed by this simple additive sequence. It is the algorithm of life, the mathematical process by which nature organizes itself. From the sound of a hammer, Pythagoras had followed the thread to the very code of biological growth. The discoveries of the Pythagorean school were not for public consumption. Initiates were bound by an oath of secrecy. For them, mathematics was not a tool for commerce or engineering. It was a sacred spiritual path. Numbers and shapes were objects of meditation, keys to understanding the divine mind. At the heart of their secret doctrine was a symbol they swore their oaths upon, the tetratyce. On the surface, it is a simple triangle made of 10 dots, but to the Pythagoreans, it was a map of creation. The single dot at the top represented unity, the origin of all things. The 2 dots below represented duality, the first division. The 3 dots represented the first true shape, the plane of the triangle, and the 4 dots at the base represented the 3-dimensional world of solids, of matter. 1, 2, 3, and 4 add up to 10, the perfect number, which for them contained all of creation. It was a geometric story of how the one becomes the many. This progression, from point to line to plane to solid, was the key to matter itself. If the universe was built on number, then the physical elements must correspond to fundamental shapes. The Brotherhood sought the primary building blocks of the universe, the perfect solids that could be constructed with absolute symmetry. There are only 5. The tetrahedron, with 4 triangular faces, sharp and piercing. The stable, solid cube, with 6 square faces. The octahedron, 8 triangles, nimble and airy. The icosahedron, with 20 triangular faces, complex and fluid. And finally, the dodecahedron, with 12 pentagonal faces, the most mysterious and all-encompassing. Centuries later, Plato would famously assign these shapes to the classical elements. Fire was the sharp tetrahedron, earth the stable cube, air the mobile octahedron, water the fluid icosahedron, and the dodecahedron, so unlike the others, he assigned to the heavens themselves, the shape of the cosmos. These 5 shapes were the archetypal building blocks of reality. But this search for the symbols of creation was not confined to Greece. Thousands of years before Pythagoras, on the walls of the Temple of Osiris in Abydos, Egypt, ancient builders carved a symbol of breathtaking complexity and elegance, the flower of life. It is formed from 19 overlapping circles of equal size. It is a symbol of absolute geometric perfection, and hidden within its curves is a treasure trove of sacred knowledge. Contained within it are the blueprints for every shape we have discussed. From it, one can derive the seed of life, the tree of life from the Kabbalah, and a shape known as Metatron's cube. And within Metatron's cube, by connecting the centers of the spheres, one finds the outlines of all 5 Platonic solids. It was all there, the same universal archetypes discovered and revered by different cultures separated by thousands of miles and thousands of years. It was as if humanity, in its deepest search for meaning, was discovering the same fundamental truths, the same geometric fingerprints of the divine. For Pythagoras, the laws he found on earth were not bound by it. The same harmony that governed a vibrating string must also govern the cosmos. He looked to the heavens, not as a collection of random lights, but as a great celestial instrument. He proposed that the planets, moving in their orbits around the earth, each produced a unique vibrational hum. Together, their orbital paths formed a silent celestial harmony, the musica universalis, or the music of the spheres. The distances between the planets, he believed, corresponded to musical intervals. Their combined motion was a symphony, one so constant and so perfect that we are born into it and therefore cannot hear it. For centuries, this idea was considered beautiful poetry, a mystic stream. But what if it was a premonition? Now, with the tools of modern science, we gaze upon the cosmos Pythagoras could only imagine, and we see his intuition echoed in the heavens. We see spiral galaxies, billions of light years across, that trace the perfect arc of the golden spiral. We find the golden ratio in the relationship between the orbital periods of planets. We see it in the structure of Saturn's rings. The celestial harmony is real. And the same principle that governs the largest structures in the universe is also found in the smallest. The ancient Hermetic philosophers, inheritors of Egyptian and Greek wisdom, condensed this realization into a single powerful maxim: as above, so below. The macrocosm and the microcosm are reflections of each other. The laws of the heavens are the laws of life. Let us journey below. Inside the nucleus of every cell in your body is the molecule that writes the score for your existence, DNA. Its structure is the iconic double helix. The geometry of this helix is precise. It is 21 angstroms wide, and its full cycle is 34 angstroms long. 21 and 34. Consecutive numbers in the Fibonacci sequence. Their ratio, 1.619, is an incredibly close approximation of phi. The code of life itself is organized by the golden ratio. We see it in the inert world of minerals. Snowflakes crystallize into six-sided wonders, a perfect expression of the hexagon, a two-dimensional slice of the cube. Quartz crystals grow with geometric precision. The very atoms that form our world lock together in lattices of crystalline perfection, forming octahedrons, cubes, and tetrahedrons. From the swirling arms of a galaxy to the helical dance of our genes, from the formation of crystals to the orbits of planets, the same patterns, the same ratios, the same geometric principles repeat over and over. As above, so below is not a mystical belief. It is an observable, scientific fact. The universe, it seems, uses the same creative strategies on every scale of existence. The intuition of the ancient mystics is being verified by the data of modern science. The blueprint is real. We have journeyed from ancient Greece to the edge of the universe and back into the heart of our own selves. We have followed the thread of a single idea, that reality has an underlying geometric structure. So we must ask the final, most profound question. If this divine blueprint is in everything around us and in the very molecules that make us, could it also be the structure of consciousness itself? What is the act of perceiving beauty? When we are moved by a piece of music, or stand in awe of a majestic cathedral, or find perfection in the face of a flower, what is actually happening? Is it possible that our consciousness, itself built upon these geometric principles, is simply recognizing its own nature reflected in the outside world? That the harmony without resonates with a harmony within? Consider the phenomenon of cymatics. When you place sand on a metal plate and vibrate it with a pure musical frequency, the sand doesn't just shake randomly. It spontaneously arranges itself into exquisite, stable geometric patterns. The higher the frequency, the more complex the pattern. The invisible world of vibration organizes the visible world of matter into geometric form. This offers a breathtaking metaphor. What if the universe itself is a kind of vibration, a symphony of frequencies playing out since the Big Bang? What if the geometric forms of nature are the cymatic patterns of this cosmic music? The world would not be a collection of things, but a unified event, a song being sung. This was the ultimate legacy of Pythagoras, not a theorem, but a worldview, that the universe is not a cold, dead machine, but a living, intelligent, knowable cosmos, and that the human soul, in its capacity to perceive order, reason, and beauty, is a direct reflection of that cosmic intelligence. The act of doing mathematics, of creating art, of appreciating nature, becomes a sacred act. It is the universe becoming aware of its own elegance through us. Our journey ends where it began, with a single seeker, contemplating a simple form. Pythagoras, looking at a seashell. We are all that seeker. The blueprint is not hidden away in some esoteric text or ancient temple. It is right here, in plain sight. It is in the way a tree branches toward the sun. It is in the proportions of your own hand. It is in the silence between your thoughts. The cosmic symphony, the music of the spheres, is still playing. All we must do is learn to listen, to look at the world with new eyes, and to see not random objects, but the intricate notes of a single, unified, geometric masterpiece. To recognize our own place within this divine, mathematical reality. Where have you seen these sacred patterns in your own life? Share your discoveries in the comments below.